workshop today we have some tube which requires a Stub ACME thread machined on one end. It's 3.5 inches diameter by 8 TPI, and this tube will be cut to 10 inches long. So it's quite a big job from a small lathe. Normally when you're working on a lathe with a long piece of material, ideally you want to support the end with a tailstock and centre, something like this. Or if you need access to the end of the material, what you want to try and do is to use a fixed steady and support it something like this. But in this case we have a problem. The material is too big to be supported by the fixed steady that I have. Now this tube is for hydraulic cylinders and it's supplied with a machine bore. It's actually machined and honed, so it's very smooth and very accurately sized on the internal diameter. So to get over this problem I've made a, should we call this, tailstock support plug. So I've machined this up so that it fits neatly in the bore. It did fit neatly in the bore. Yeah, it's really a perfect fit in there. It's practically size for size. The centre in the back here to support it with the tailstock. So I've got 3 brass pins in here, and I've got 3 screws. So these have got a tapered end. They'll raise the brass pin so that it clamps to the inside of the tube. And they're quite a neat fit. I've got some grub screws in the back here. So I used these grub screws to clamp the pins while they were being machined, and I just keep a small amount of pressure on there. There's a flat on the pin, so putting the grub screw up against there keeps it in alignment. So just bring that up level, flush, just below, that's it there. Okay, so I have a recess here, so the idea is when I fit it to the tube I can put it about there, so I have access to this face to machine this face. And then once I've machined this face, I can push it right in and turn the diameter. I'll show some footage of this being made at the end of the video, but the purpose of the video is to show the screw cutting of the Stub ACME thread. So let's get cracking. This is what a Stub ACME thread looks like. I decided for this job to use a threading insert. Cutwell in the UK sell Stub ACME inserts at a very reasonable price. You can see here that with the plug in that position I can machine the full width of the end of the tube. I'm just turning up the end enough for the material to clean in. Now that I've pushed the plug in up to the shoulder, I've got much better security. I'm not relying on the internal clamps. There's just over 1mm in diameter to come off. I'm taking 0.4mm depth of cuts, so that's about 15 thou. A light cut and fine feed means I'm not getting good chip action on the cutting tool. In this particular setup I'm fighting a lack of rigidity and therefore need to take fine feed cuts. Taking a spring cut to get a size on diameter. Getting a dimension to take a finishing cut. Putting the chamfer on the end. Machining in a recess for thread run out. First thread cut. There's some shattering going on. You may not have noticed, to reduce the chatter I've slowed down the spindle speed. Keeping the spindle speed lower and taking a decent sized depth of cut tends to reduce the chatter. A back geared belt driven spindle combined with a variable speed drive is a great combination. It provides a high torque at a very low spindle speed. I'm taking 0.1mm depth of cut, that's about 4 thou. It will take about 20 passes or so to get the full thread depth. I'm using a thread dial indicator, putting an 8 TPI thread on an 8 TPI lead screw. I can therefore engage the carriage at any line number. Just filling up the crust of the thread with some emery cloth. Adding a small chamfer around the corner of the threads. Now I'm removing the first thread for about half the circumference. This is standard for Acme and Stub ACME threads. Off camera I machined an O-ring groove in the face of the tube. Job done. Thanks for watching.